Welcome to my channel, The Coding Cat. This channel will go over how to solve LeetCode problems in C++. This is the two-sum tutorial. In every problem, we will go over a series of steps to solve the problem. First, the problem statement, the intuition, the brute force approach, the optimal approach, the code walkthrough, and the time and space complexity, and a small tip at the end. So you can take a moment and pause and read through the problem statement, and we'll go through example 1 and example 3. So example 1, the nums array is 2, 7, 11, and 15, and the target is equal to 9. So as we can see here, the numbers in the array nums that equals to 9 is 2 and 7. So if we go by 0 indexing, we can see that the answer lies in the sum of index 0 and index 1, which is why the output will equal the vector 0, 1. In example 3, we can see that the nums array is equal to 3, 3, and the target is equal to 6. Now, remember that the problem statement says that you may not use the same element twice. The index, or the number that lies at the index 0 and the number that lies at the index 1, which is 3 and 3, will sum up to be 6. So the output here will be 0, 1. So if we look at example 1 with our intuition, we will iterate through the array one number at a time. So if we're on the value 2, we'll have to try and look for the target, which is 9, minus the number that we're on, and we'll have to try and search for the value 7. So before we go through the optimal approach solution, let's go through the brute force approach. The brute force approach is generally the easiest solution to come up with, but it often is the most inefficient method. However, it is important to come up with anyways for interviews, as you can not only explain your thought process to the interviewer, but you can also come up with more efficient solutions on your own as you go through your own brute force solution. The brute force solution would be to go through the array, and for every number, you iterate through the rest of the array to see which other number in the array will sum to reach the target. The reason this approach would not be the most optimal is due to the possibility of going through the array many more times than is needed. The optimal approach would be to find a method where we could find a possible partner or complement for any number in the array, where the sum of those two numbers would add up to the target. When we think of finding numbers in an array in terms of data structures, the best data structure to use would be a hash map. The hash map would need a key and a value. The key would have to be the element of the array, as that is how we can find a value, by searching for the key. The value would be the index where that key is located in the main array. We would start by passing through our array for the first time. During this first pass, we want to add all the elements into the hash map along with the index where that element is located. For example, when we look at example 1 here, this is what the hash table for that particular array would look like. So let's break this hash table down. We can see that for the key, which is the element in the array, the value is the index at where that element is located. So for example, for element 2, it's located at index 0, so the key value pair would be 2, 0. And for element 7, which is located at index 1, the key value pair would be 7, 1, and so on and so forth. So during our next pass of the array, we would look at each value and see if its partner or the complement also exists. We do that by searching for the target minus the current number. If it is found, we take the index of that current number, which in this example would be 0, and the index of its complement, which in this example would be 1. And we would return those indices as a vector. So let's go ahead and code this out. So first, we're going to have to create our hash table. So this is the syntax to create it, and I'm going to name it nummap. Remember that there's two data types that go inside of the pointy brackets for the hash table syntax, and those two data types are the key and the value data types. Remember that both of these data types have to be integers because the key, which is the element, and the value, which is the index, are both integers. So we're going to start by creating our first for loop. And this for loop is to pass through the nums array for the first time for the sake of populating our hash table. We're going to have to populate the hash table with the key, which is the element in the array, and the value, which is the index. So now let's go ahead and actually populate the hash table. And this is the syntax for doing so. So num map at nums at I is equal to I, where nums at I is my element and I is where that element is located. So nums at I is my key and I is my value. Now, for simplicity purposes, you can create an integer for the second index in the return vector. So I just really like doing this because it helps me stay a little bit more organized in terms of what I'm setting my values to and just to understand what I'm returning better. So now we'll have to create another for loop to go through the nums vector one more time. Now this is to basically find if the complement exists in our hash table for the current index of the for loop, and that if it does, we want to take the index of where that complement is located in our hash table and return the indices of our current index and the complement's index. So we'll have to set an int complement equal to target minus nums at I, where I is the index of the current iteration of the for loop. Now, our if statement will have to check whether the complement is found inside of the num map. So the way we do that is by saying nummap.find complement is not equal to nummap.end, which basically means that the complement is a key that is found inside of the num map. We also have to check if nummap complement is not equal to I. So remember that the problem statement says you may not use the same element twice. So basically it's trying to say that you can't use the same index and add it up with itself to equal the target. So it has to be two different indices inside of the vector to be returned. So now if both of these constraints are met, then you can set second equal to nummap at complement, where nummap at complement is the index where the complement is found in the hash table. So now you would return the vector I, second, where I is the index of the current iteration of the for loop, and second is the index of I's complement. So the element at index I and the element at the index second will add up to reach the target. Now, remember that you'll have to have some kind of a catch-all return. So eventually you can just return 0, 0, so that's kind of just your catch-all. You would probably expect for the code to not reach that point because the problem statement says that each input would have exactly one solution. So your return statement will definitely be reached before you reach the point return 0, 0. All right, so the hardest part is now over. Now comes the time and the space complexity. So let's start with the time complexity. So on lines 8 to 10, we have a for loop, which is going through the nums array one time. So that time complexity would be O of n. We also have another for loop on line 16 that is going through the nums array one more time. So that is also O of n time. So 2 O of n time is basically just O of n time. Now let's look at the space complexity. So because we are creating a new hash table that has the same number of entries as there are elements in the nums array, that would be O of n space. So the time is O of n and the space is also O of n. So one super quick tip is how LeetCode lets you put your own test cases. So it's very good coding practice to create test cases and run through them in your head to make sure that your code is going in the right direction. So for example, in my test case here, I've put 3, 4, and 4. So right off the bat, we know that this is an invalid test case because this array will have 2 solutions and the question is saying that you should have exactly 1 solution. So this is a good way to ensure that you are actually understanding the problem and you will go in the right direction after that. Alright, so that's all for today's video. If you like the video or you have any feedback, feel free to leave them in the comments below and make sure to like and subscribe, and I will see you in the next video.